Dear all, in this video we will be reviewing Fourier series. So Fourier series is one of those series we could express periodic functions using sine and cosine waves in the series. These are really useful in physics and engineering, and we will be reviewing a little bit about them. So f of x, our Fourier series is defined by f of x equals to this function a sub 0 plus sigma n equals 1 infinity a sub n cosine of n pi x over L plus sigma n equals 1 infinity b sub n sine n pi x over L. This is the Fourier sine series, the Fourier series. And L is expressed by the period. We mean the period when we say L. And we have three constants, three terms that we did not define. So the terms will be a sub 0, and it is defined by 1 over 2L from the integral negative L to L f of x dx, and a sub n equals to 1 over L negative L to L f of x cosine of n pi x over L dx, and the last one is b sub n equals to 1 over L, the integral from negative L to L f of x sine n pi x over L dx. Now, these coefficients are our Fourier coefficients, and if you see something like the Fourier sine series, we will be calling that for the a terms. Okay, so we will only have the a terms for Fourier sine series, and for Fourier cosine series, actually that's for the Fourier cosine because we have a cosine here, and for the Fourier sine series we would have only the b sub n term. So this is a very important note, and the reason being is because here's the thing: we have a symmetric interval, the symmetric interval and an integral, okay? And if we have an odd function, our integral from negative L to L will be what? Well, if you have an odd function, that will be 2 times, actually it will be 0, right? The integral of an odd function is always equal to 0. Likewise, for a sub n, we have an odd function times an even function, and odd times even is going to be odd. So that's why that's also equal to 0. So this is why odd functions will only give you Fourier sine series. If we are dealing with even functions, then yeah, we would have those terms, but then we would not have our b sub n term, which is odd function times sine of this n pi x over L. Well, here's the thing: if we have an even odd function times an odd function, we will have an even function. That's good. If we have an even function in the integral, what we could rewrite that as is basically 2 times this integral but from 0 to L. Look at this little definition on the right. It says this integral, this symmetric integral, will become 2 times the integral from 0 to L. And if you actually graph a cosine graph or an even function, you can actually understand why these functions integrals behave this way, because when we're doing with odd functions, imagine an odd function, it would cancel the areas out when you do it in a symmetric interval. But if we do an even function, well, we would actually have the same area, but it would actually just be multiplied by 2. So that's why for odd and even functions, our integrals behave this way. So now we will be covering some problems on Fourier series to understand how we can define functions as Fourier series. Now let's work on this problem. So we are asked to find the full Fourier series of f of x equals to x in this interval negative pi to x to pi. So the first thing we want to note is that L is going to be equal to pi because our period is going to be equal to pi. Okay. And other than that, another important information that x is an odd function. Okay. X is an odd function. So what does that mean? We're not going to have an a sub 0 or a sub n terms. We're only going to have a b sub n term. So if we go ahead and use it, we would have b sub n. Okay, let's try to solve for b sub n and plug it into our Fourier series. So I just want to say a sub 0 is equal to 0 and a sub n equals to 0 as well. So 1 over pi, okay, of negative pi to pi of x sine, and look at the domain, we will be dividing with pi, so these pi's will cancel each other out, so we will have sine of nx dx. Okay, however, look at this. We will have a what? This is an odd function times an odd function, so the integrand is odd, where our interval is symmetric, so we can just rewrite this as 2 over pi from 0 to pi x sine nx dx. Alright? Now that we have this, we can solve this integral using integration by parts. I will use my DI method, and I will have x1 0, and for this one we will have sine nx. The integral of sine is negative cosine, so we will have 1 over n, negative 1 over n cosine of nx. And the integral of cosine is just going to be sine, so we're going to have negative 1 over n squared sine nx. Okay, and write a plus minus plus and multiply to get the integration by parts. So our result of this integral will be negative x over n cosine of nx plus sine nx over n squared, evaluated from where? From 0 to pi. 0 to pi. Okay? Now that we know this, we can just go ahead and plug that for this interval. So we will have negative pi over n cosine of pi x. Cosine of pi x, guys, will be negative 1 to the n power. The reason is because we will have pi times x, pi times n, pi times n, and if n is 1, we will have a negative 1, and if n is 2, we will have a 0, 1. So our cosine of nx will be alternating between negative 1 and positive 1. Plus, sine of pi is just going to be 0, so that's why we're not going to be doing that. And now we can subtract from the 0 version of this, so cosine of 0 is 1, but we have a 0 for this one, so that will be cancelled out, and sine of 0 is also going to be 0, so this is why our results of this integral will be negative 1 to the n times pi n, and we are also, don't forget that we are multiplying with 2 over pi. Okay, so our results would be negative 2 over n to the negative 1 to the n power, which is also 1 over n times negative 1 to the n plus 1 power. Okay, and if we go ahead and plug this into our solution for Fourier series, okay, Fourier series will look something like this. Okay, and well, a sub 0 and a sub n were equal to 0, so we're just going to cross these out, and f of x will be equal to the summation of n equals 1 to infinity of 1 over n negative 1 to the n plus 1 times sine of n pi x over pi, which is just going to be sine of n x. Also, not to forget, we would have a 2 attached to it, because for b sub n we had a negative 2, and this should have been a 2 times 1 over n, so this 2 will also be a constant, and this will be the result of the Fourier series for x.